Hello, welcome to 8.1, 8.4, functions, domain, and range. A function is a rule that assigns to each input number a definite, one and only one output number. The set of all inputs is the domain, and the set of all outputs is the range. Function notation. The notation y equals f of x is called function notation. The input is x, and the output is y. And the name of the function is f. So you can see here that the name of the function is f, the input is x, and the output is y. The variable y is called the dependent variable, and the x value is called the independent variable. The expression f of 4 equals 28 is read f of 4 equals 28 and indicates that f's output 28 when the input is 4. A function computes exactly one output for each valid input. The letters F, G, and H are often used to denote the names of functions. So let's get started with some examples. Example number 1. For f of x is equal to x squared minus 5, find f of 3. So our input is 3. That means wherever there is an x, substitute in 3. And I'm going to go ahead and put this 3 in parentheses, which is the same as without the parentheses, but you'll see why on the next example. So 3 squared is 9, and 9 minus 5 is 4. So over here on the right, f of 3 is equal to 4. And down here, we can write it as an ordered pair. The input is 3 and the output is 4. If we want to find f of negative 5, we have negative 5 squared minus 5. The parentheses here are very important because this is negative 5 times negative 5, which is 25. So f of negative 5 is 20, and we can write this as an ordered pair, negative 5, 20. Example 2. We want to find f of negative 13. So wherever there's an x in the function, put in a 13. So we have 4 over negative 12, which is equal to negative 1/3. And if we want to find f of 4, we're going to substitute in 4 wherever there's an x. So over on the right, f of negative 13 is equal to negative 1/3. We have the ordered pair negative 13, negative 1/3. And f of 4 is equal to 4/5. And so we have the ordered pair 4 and 4/5. There we go. Example number 3. we want to find f of -4. Wherever there is an x, substitute in -4. I suggest whenever you substitute in a number for a variable, you use parentheses. Now from here, we're just going to calculate this. So f of -4 is equal to 31. And now we want to find f of 4. And the same thing here is I'm going to go ahead and use parentheses whenever I substitute a number in for a variable with an exponent. So f of 4 is equal to -89. And then to write it as an ordered pair, we have 4, -89, and -4, 31. Example 4, we have an absolute value. We want to find f of 5/4. So sometimes I call these plug and chug. You're going to plug in what x is. And then the chug part is the calculation. Uh, 5 minus 5 is 0. The absolute value of 0 is 0. And then we want to find f of -3. Be sure to follow the order of operations. We need to multiply -4 times -3. So we have 5 plus 12, 17, and the absolute value of 17 is 17. So moving right along. Example 5, the function is a square root. We want to find f of -5. So we're going to take the square root of -5 plus 5, which is equal to 0. And then we want to take f of 20, take the square root of 20 plus 5. The square root of 25 is equal to 5. So f of 20 is equal to 5. And as an ordered pair, it would be the ordered pair 20 and 5. Example 6, we have a cubed root. F of -10 is asking us to find the cubed root of -10 plus 2. The cubed root of -8. What number times itself 3 times gives you -8? and that is -2. So we have the ordered pair -10, -2. Finishing up here, we want to find f of 25. We want the cubed root of 25 plus 2, which is the cubed root of 27. What number times itself 3 times gives you 27? And that is 3. F of 25 is 3. It's the ordered pair 25, 3. Now let's extend this to variables. Example 7, we want to find f of a. F of a means wherever there is an x, you want to substitute in a. There you have it. And if we want to find f of a plus 9, wherever there is an x, we're going to substitute in a plus 9. Now we'll distribute the -8. And combine like terms. There you have it. Well, let's take this a step further. All right, number 8. This time we're going to substitute in a plus 1 wherever there is an x. And now we're going to simplify this. Keep in mind that a plus 1 squared is a plus 1 times a plus 1. That needs to be multiplied. So a plus 1 times a plus 1. Some of you would say, oh, this is where we FOIL. You're multiplying. So yes, FOIL is first out, inner last, which will help you multiply this. We get a squared plus a would be 2a, and 1 times 1 is 1. Let's distribute that 5. Let's distribute the 6. Let's combine like terms. There we go. I would highly recommend you practice number 8. You will see this one again. So we can also find function values from a graph. So letter A is saying f of 5 equals, well, we know that the 5 is the x value. So we're asking you to find the y value. So if you go the x value of 5, and then go to where you hit your graph, that is the y value. And this y value is -1. Letter B, the x value is -5. So go to the x value of -5 And what is the point on the graph there? Well, the y value is 0. Letter C, go to the x value of -4. And what is the y value? It is 2. In letter D, if the x value is 0, then the y value is 0. So all you're really doing is looking for the ordered pair. I give you the x value, you tell me the y value. We can also find function values from a table. Here we have f of 0, where we remember 0 is the x value. So what is the y value that goes with f of 0? That will be 5.5. And f of 2 equals, let's go to the x value of 2. And what is the y value? 3.7 or 3 7/10. All right, let's look at a diagram. We're going to use the diagram to find the domain and range. This first oval represents the domain, and the second is the range. The first thing we want to do is write this as a set of ordered pairs. A set has the set brackets, and we want to write the ordered pairs. So the 2 goes to the 4. Then we have 4, 2, 8, 11, and 9, 1. And you have a question like this on your homework, you got to remember to put in the commas between your set of ordered pairs. Then it's asking us for the domain. We have already included the set bracket, so we can list the domain: 2, 4, 8, and 9. And the range are your y values: 1, 2, 4, and 11. And this picture represents a function because each x value goes to exactly one y value, which was the very first thing I highlighted. So on this next diagram, does this represent a function? You are looking for each x to go to only one y value. And this is not a function. Because it is not 1 to 1, -35 goes to both a y value of 1 and a y value of 22. So this is not a function. You're looking for the 1 to 1. Let's look at this table. Does the table represent a function? Does each x value go to only one y value? And if you just look at your x's, you have 0, 1, 2, 3, 4. And since they don't repeat, that's one way to quickly determine whether or not it is a function. So yes, this is a function. And if you just kind of sketched a picture, 0, 3, 1, 3, 2, 5, 3, 6, 4, 7, it would kind of look like that. So you can see each x value only goes to one y value. So what about our next table? Does the table represent a function? The x values are 0, 1, 1. So we can see right here that the x value of 1 has a y value of both 3 and 5. If we sketched a quick picture, we would have 1, 3, 1, 5, 2, 6, and 3, 7. But it is not 1 to 1 because this x value has two different y values. We're going to talk about a vertical line test. So one of the things you will be asked to do is to determine whether a set of ordered pairs given by a graph is a function. Since each x value must correspond to exactly one y value, we can use what is called the vertical line test. And simply stated, if you can draw a vertical line and cross the graph in two places, it is not a function, because that means x has two different y values. So vertical line test, if every vertical line intersects a graph at no more than 1 point, then the graph represents a function. So if you can draw a vertical line and cross the graph in one place, then it is a function. So number 1 would be yes, this graph is a, yes, this graph is a function. But number 2 is no. We can draw infinite many vertical lines and we'll cross the graph in two places. So this is not a function. So we've seen a couple different, actually 3 different cases. We've seen a diagram, a graph, and a table that we've determined whether it is a function or not. All right, in this next set of problems, we are going to use a graph to determine the function's domain and range. So domain are your x values, range are your y values. And you can read the important information at the top of the screen. Remember, the handouts are also available in Ivy Learn. All right, so what we want to do here is we want to determine the domain and range of the graph. So your domain are your x values and range are your y values. So let's look to see what values of x this first graph is defined from. So it's going from here to here. So domain are like the walls. So the domain is from -7 to 5. All right, the -7 has a bracket on it because it is a closed circle. The 5 has a parenthesis because it has an open circle. So down below on our worksheet, it's asking for the range. So I'm going to go ahead and find the range. The range are your y values. So it's defined between these y values. So your domain or your range are like the floor and the ceiling. So the lowest y value, the smallest y value that we have is -3. And the largest y value is 1. Again, the -3 has a bracket on it because it is a solid circle. The 1 has a parenthesis on it because it is an open circle. All right, let's look at the next picture. Your domain are your x values. So we're going from here to here. Domain are like your walls. So we're going from -4 to 5. They're both parentheses because they're both open circles. The range are your y values. So here's the floor. That's the lowest y value that we have. And the highest y value is here. So that's -2. And it's solid, so it'll be a bracket on -2. And we go up to number 5, or to 5. And 5 has a parenthesis on it because it is an open circle. And the next example, notice that this graph has arrows on it. The graph is not contained between certain values of x. This graph goes on forever. So the domain is -infinity to infinity. If those arrows weren't there, it would be different. But this graph is defined for all x values. So if I wanted to put in or look at -5, this graph would continue up and I could get a value for it. The range, the smallest value of y is at 0. And it continues to infinity. So the range is from 0 to infinity. A couple more things with domain. The domain of any function defined by a formula or an equation is the largest set of real numbers input that each produce a real number as an output. So we want to find the domain of each of the functions. And the first half of the class for your midterm in chapter 7, we know that you can't have a fraction with a denominator of 0. So this kind of resorts back to that same idea. So whenever we have a function that is rational, that means we have a fraction, we know that the denominator cannot be equal to 0. In chapter 7, we ask you, where is the function undefined? And you would have said x plus 2 equals 0. Since we're finding domain, we have to write down all the inputs that are valid. So x cannot equal -2. We want to write our answer in interval notation. So I'm going to go ahead and graph a number line so I can kind of see what's going on. So here's my number line. I can have everything on the number line except -2. So as an interval, I go from -infinity to -2, union -2 to infinity. So what I'm about to highlight, these are the same answers. But since the directions say we must write it in interval notation, you must write it as an interval. All right, number 2, g of x is equal to 4x divided by x squared plus 5. We know that the denominator cannot equal 0, so x squared cannot equal -5. Well, x squared is never going to equal -5 anyway, because a positive times a positive is a positive, and a negative times a negative is a positive. So it's not going to be a real number. So then our domain is defined for every number. So that will be negative infinity to infinity. Number 3, c of x is equal to 9 divided by x squared minus 9. We'll take the denominator. It cannot equal 0. We'll go ahead and factor. So I'm going to write this again on a number line. I put the big circles on the numbers that it cannot be. So it can be everything except those two numbers. So by drawing a number line, it helps me see the intervals. I can go from negative infinity to negative 3. It cannot include negative 3, but I have that space between negative 3 and 3. And then I cannot include 3, but I go all the way to infinity. So this is a 3-part interval notation. Number 4, g of y is equal to y plus 9 over y squared minus 9y. The denominator cannot equal 0. We factor. Set the factors not equal to 0. The number line just helps me write the interval. So I can have everything on the number line except 0 and 9. So my interval is from negative infinity to 0, not including 0 or 9. And again, it's a 3-part interval. Number 5, h of y. We can see we have a fraction. The denominator cannot equal 0. We will factor the factors of negative 8 that add to 2. Set each of your factors equal to 0 or not equal to 0. So x cannot equal negative 4. And x cannot equal 2. The number line is not necessary. Just helps me write all 3 of my intervals. And there you go. The other function that has a restricted domain is a square root. The domain of a square root function is all non-negative real numbers. A square root function will evaluate to a real number as long as the radicand, what is under the square root symbol, is greater than or equal to 0. So when we have to find the domain of a square root, we will always take the radicand and set it greater than or equal to 0. So x is greater than or equal to 2. And the directions state to find or to state this in interval notation. So this would be 2 to infinity. You have two functions that have restricted domains. You cannot have 0 in the denominator, and the radicand of a square root must be greater than or equal to 0. Number 7, j of x. We have a square root. We want to find the domain. We know that the radicand must be greater than or equal to 0. I'm going to go ahead and subtract 10 from both sides. Recall that when you divide an inequality by a negative, you must reverse the inequality sign. So x is less than or equal to 5. In interval notation, this is negative infinity to 5 with a bracket. All right, number 8 is a quadratic. It's asking for the domain. There are two functions that restrict your domain. You cannot have a denominator of 0 and a square root. The radicand must be greater than or equal to 0. Number 8 isn't either of those two, so we know the domain is all real numbers. You can substitute any number in for x, and it can produce a real number. And number 9, same thing. It doesn't meet either one of the two conditions for restricting the domain, so the domain is all real numbers. And that does it for this video on functions, domain, and range. See you next time when we will graph these. Bye for now.